All right, let's talk Snowflake. Today, we're going to pull back the curtain and follow the incredible journey of a single SQL query. From the moment you hit run all the way to the second you get your results back. So let's dive right in and see how all that magic really happens. It's a great question, right? You type what feels like a simple command, maybe just a select star with a where clause, and behind the scenes, this huge, highly coordinated operation just springs to life. So what is actually going on in that black box? Let's trace the path from start to finish. Okay, so every story needs a hero. And in our story, the hero is your SQL query. The second you submit it, doesn't matter if it's from the Snowflake UI, a BI tool like Tableau, or some custom app, its journey officially begins. Now, you might think your query goes straight to the computers that do all the heavy lifting, but nope. Its very first stop is here, at what I like to call Snowflake's mission control, the cloud services layer. This is the central brain for the entire system. It's where all the intelligence lives. Before a single byte of your actual data is even touched, that simple line of SQL has to be turned into a super efficient battle plan. This is the planning phase, and honestly, this is where most of the real magic happens. So what is this cloud services layer, really? Think of it as the central nervous system. It's a totally separate service that coordinates everything. It handles your login, it manages all the metadata about your tables, and most important for our story, it houses the query optimizer. This is the architect that's going to make our query a wild success. Inside this layer, your query goes through this lightning-fast series of checks. First, Snowflake parses it, to make sure your syntax is right and that you actually have permission to see the data. Then it creates a basic, logical blueprint. But the key is that last step, optimization. This is where that simple blueprint gets transformed into a masterpiece of efficiency. And this is where things get really, really clever. The optimizer doesn't just blindly follow your instructions, it's actively rewriting them for speed. It'll figure out the best order to join your tables, it'll push your where clauses down to happen as early as possible, and it will completely ignore any columns you didn't ask for. It's all about doing less work before the work even begins. But of all the optimizer's tricks, one of them stands head and shoulders above the rest. It's probably the single biggest reason for Snowflake's legendary performance, and it's called micro-partition pruning. And I am not exaggerating at all. If you take just one thing away from this whole explainer, it should be this. Pruning isn't just a feature. It is the fundamental design choice that makes the entire system fly. And this right here illustrates the difference perfectly. Traditional databases often have to do a full table scan. They have to read every single row just to find what they're looking for. But Snowflake, it knows exactly where your data lives. It can surgically target and read only the tiny blocks of data, the micro-partitions that are actually relevant to your query. So let that number sink in. In a lot of typical analytical queries, Snowflake can eliminate over 99% of the data from even being considered without ever reading it from disk. Its speed doesn't come from reading data faster, it comes from reading massively, massively less data to begin with. So how does it do this? Well, it's all thanks to metadata. Every single micropartition has this rich set of statistics stored about it in the cloud services layer. This metadata is like a super detailed map. It tells the optimizer the minimum and maximum values for every column inside that block. So if you're asking for sales data from January, the optimizer doesn't scan the table. It just looks at its map, sees which blocks contain January dates, and tells the system to completely ignore all the others. It is absolutely brilliant. Okay, so we've got the perfect pruned execution plan. It's smart, it's efficient, it knows exactly what data to touch. Now, it's time to hand it off to the workforce and actually do the work. But first, Snowflake's checks for shortcuts. It's got this multi-layered cache system. Why do work if you don't have to, right? If anyone in your account ran the exact same query recently, boom, the result comes back instantly from the result cache. If not, it checks the local SSD cache on the computers themselves. Only as a very last resort does it go out to remote cloud storage, because that's the slowest step. Once it's clear the work really has to be done, the plan gets sent to your virtual warehouse. And this isn't just one computer. Think of it as a cluster of compute nodes, an elite squad that just spins up on demand, ready to execute your query in parallel. And inside that warehouse, it's all about parallelism. The query plan is chopped up and distributed across all the nodes. Each node reads its assigned micropartitions and processes the data in this highly efficient, columnar way. And when you need to do things like joins or aggregations, the nodes just shuffle the data between themselves to get the job done. It's like a perfectly choreographed dance. The nodes have done their jobs. The data has been scanned, filtered, aggregated. We are now in the final phase of our query's life. We are on the home stretch. And finally, those partial results from each node in the cluster get combined into one final result set. That data set is then streamed right back to you, and once the job is done, Snowflake cleans up after itself. And if the warehouse is sitting idle, it will automatically suspend to save you money. Mission complete. So there you have it. From a simple line of SQL to a massively parallel, super optimized execution plan, that is the life of a Snowflake query. And understanding this journey, especially the power of that pruning, doesn't just demystify the system. It helps you write better, faster queries. The next time you write a where clause, you'll know you're not just filtering, you're handing the optimizer the map it needs to win.